Assalamu alaikum everybody, and thank you for joining us for today's presentation. My name is Hamid. I'm the product architect for GVERSE GeoGraphix. With me is Mumtaz Meher. He's the director of product delivery and looks after the entire geographic suite of tools. He'll be assisting me in this presentation today. We're also joined by Suhail Rashid, Umar Manzoor, and a couple of other folks from LMKR. During today's session, there we go. During today's session, I will be very quickly going over what GeoGraphix is and all the modules that make up this fully integrated interpretation suite. My focus, though, will specifically be on GVERSE GeoGraphix, the seismic interpretation package for GeoGraphix, and I will give you an overview of the main features of this application. Now, I will also mention the add-on modules that work hand in hand with GVERSE GeoGraphix for some advanced workflows, but I will be spending most of my time answering the specific questions that we received from PPL users via Mr. Irfan Latif. We will also have an open Q&A at the end of the session, so I will request, just like Mr. Irfan just requested, that if you have any questions, please hold them until we get to the end of the presentation. If you have a question that can't wait, please use the chat option. Just type in the question, and Mumtaz can help me in answering that right away in the chat window. But before I get to the overview of the application and the user questions, and while I still have your fresh attention, let me tell you how we think PPL can benefit from GeoGraphix. First on that list is the fact that we are a fully integrated geological and geophysical interpretation solution. And GeoGraphix as a software has been around since the 1980s. People around the world, including, I believe, at PPL, have drilled a lot of wells, hundreds of thousands, based on interpretations made using our tools. We are a complete package that has been around a long time, used all over the world, and we come at a fraction of the cost of some of the other packages on the market that have, in terms of variety at least, as many tools and workflows as we offer in GVERSE GeoGraphix. But I admit this fact is very generalized and probably applies to any operator company. It doesn't help me answer the question, how can we specifically help PPL? How can we make your life easier and assist you with your job and your everyday tasks? I think one of the best tools specifically for you guys is GVERSE Connect. That's our Petrel connector. It sets up a seamless connection between your GeoGraphix project and your Petrel project. And now Petrel is a good software. It has a lot of features, some very advanced workflows, but you have to pay a premium for it. And because it costs so much, a lot of companies end up sharing licenses between users. So they have many users, but just a few licenses. That inevitably leads to loss of productive time, delays, sometimes even friction between colleagues. With GVERSE Connect, you can do a lot of your work in GeoGraphix, and when you want to use Petrel, you just transfer your interpretation to your Petrel project and go from there. So PPL can leverage this two-way communication between GeoGraphix and Petrel to split the workload between the two applications and thereby enable your team to be more productive. Another unique feature, which I think is very useful for anybody working in this geographic area, in the geological setting of Pakistan, is the ability to mark multi-Z horizons. Very useful for thrust faults and compressional regimes. This is basically where your horizon can have overlapping peaks, and you can follow the horizon all the way to the fault plane for both the hanging wall and the footwall. This feature works on 2D seismic, which is another strength of ours that I think can complement your workflows. Pakistan has a lot of 2D data, and we are good at handling large amounts of 2D lines. We've also recently made significant progress in our 2D workflows, including our line balancing workflows. And many companies, many big companies like EOG Resources, for example, which is one of the bigger oil companies in the USA, about $50–60 billion market cap, they use us as the main tool for all their 2D interpretation work. By the way, EOG, they're also very heavy Petrel users, and they also make use of the Petrel Connect app to establish communication between their Petrel and GeoGraphix projects. They can certainly afford Petrel licenses, but they prefer GeoGraphix for doing their 2D interpretation work. So these are just some of the areas which I think, this is my opinion, going off the information and assumptions that I have. These areas are where we can help you make your processes more efficient, your work easier, and maybe even more productive. But as I go through this presentation and give you guys an overview of everything we can do, hopefully you guys can also spot some more areas that complement workflows specific to PPL and might address problems that you face or are trying to solve. So this next section of the presentation will give you a high-level overview of the entire suite, so you can see and decide for yourself which parts of your workflows can be addressed by our tools. As I've mentioned quite a few times now, GeoGraphix is a fully integrated end-to-end interpretation solution. Here I've broken down the entire software by discipline. So we have tools for mapping, geology, petrophysics, geophysics, modeling, presentation tools. All of this is tied together by a shared database and common project management tools, which enables tight integration between all these different applications. Here's a look at some of the tools that make up each of these categories. The project is the heart of your interpretation, as with any other software. And it is, of course, as you would expect for a software of this scale, a multi-user environment. Many people can work in the same project at any given time. We also support several different deployment configurations, including cloud-based setups or client-server configurations with one server or many different servers. Our data management tools include Wellbase, which is basically our database containing all your well data. It is one of the most complete data models in the industry. It can handle hundreds of thousands of wells very efficiently. We store all sorts of well-related data, production data, cores, microseismic, proposed surveys, and just so much more. And now we're bringing in integration with Spotfire, which is a data analytics tool to help detect non-obvious relationships that may exist in all that data that we store. Query Builder is our advanced search tool, very powerful too. Lets you find anything you need in Wellbase using predefined filters or by creating advanced filters yourself. We also have a series of tools to manage other data associated with the project, including permitting and leasing information. Our mapping tool, GeoAtlas, is considered one of the best in the business. For geologists, we have easy cross-section building tools in XSection and Smart Section. So the two things geologists love to do, build cross-sections and create maps, we do both workflows really well. GVERSE Geomodeling lets you build earth models for your geologic interpretation, and all your geophysical interpretation can be incorporated into this earth model. So we do dynamic depth conversion using velocity models created from geophysical data. You can control conformance of your surfaces using your horizon picks within this geologic domain. Well tops that you pick here in geomodeling or Smart Section are available in geophysical tools via the database. Everything is live and updated in real time. So we have full connection between geophysics and geology. We also have a full-fledged petrophysics application for building petrophysical interpretations, working with log curves, splicing, editing, digitizing, creating user-defined equations, building models, cross-plotting, everything you'd expect in a petrophysics application, and then utilizing all this information in your geological and geophysical work. For geophysics, which is today's focus, and so I will not spend a lot of time here talking about it, because I will cover this in detail during the rest of the presentation, but we have tools for your basic, intermediate, and advanced level workflows covered by all of these different applications listed here. Finally, our engineering tools, which help you plan wells and your field, including your geosteering workflows. Okay, so that's an overview of the GeoGraphix system. And we play well with some of the leading names in subsurface interpretation. We have a seamless connection with Landmark's decision space. GeoGraphix for OpenWorks sits directly on top of the Landmark database and bypasses GXDB, which is our own database. So you can actually work concurrently on Landmark and GeoGraphix using Landmark and GeoGraphix on the same project. We also have exchange tools that can transfer well and seismic data between Landmark and GeoGraphix. So if you prefer using GXDB, you can use our exchange tools to transfer data from Landmark over into the GeoGraphix world. But I guess more relevant to you guys is our connection with Petrel. We have a connector called GVERSE Connect that can create a direct connection between your Petrel project and your GeoGraphix project. You can easily transfer your well tops, your log curves, grids, maps to Petrel, or get them out of Petrel into GeoGraphix. Excuse me. Seismic as well. For the moment, we're only supporting 2D seismic, but soon we will have support for 3D seismic as well. Your faults and horizons, you can also bring in and out of both applications. So if you want to use Petrel for your advanced workflows, for reservoir modeling, or anything else that you think Petrel does really well, you can just transfer data to your Petrel project, execute your workflow, and get your results. So GeoGraphix is a complete interpretation solution that works well with the big boys from Schlumberger and Halliburton. But what can GeoGraphix do as far as geophysical interpretation is concerned? That's what we're gathered here to discuss today. So let's take a look at GVERSE Geophysics, which is the main seismic interpretation solution for GeoGraphix. A bit of history before we move on. We used to be called SizeVision. Back in 2017, we rebranded, and we are now known as GVERSE Geophysics. The rebranding happened because since 2017, we've put a lot of resources in bringing our seismic interpretation capability at par with some of the more established geophysical solutions. Since then, we've added a great new 3D viewer, advanced horizon and fault interpretation workflows, including automatic fault extraction, geobody interpretation, interactive synthetics, improvements to our depth conversion and velocity modeling, a cross-plotting tool, better line balancing, and much, much more. And I may be biased, but I think we've not only achieved parity with the likes of IHS Kingdom and even Petrel, but I genuinely believe that in some areas we've actually exceeded our competition. And I hope to show that to you today. To top it all off, for most of our features, we covered them in the base license, so we cost a fraction, as little as 1/3 even, compared to some of our competition, because they're synthetic, our automatic fault algorithms, velocity modeling, all of this is included in the base license. We don't have separate licenses for these workflows, and some of these are very crucial elements of a seismic interpretation. Let's get down to the specifics and start from the very first step. How do we handle data in GVERSE Geophysics? You can, of course, work with 2D or 3D seismic. You can have a large 2D project or a multi-survey 3D project or a combination project with both 2D and 3D data. Our architecture is 64-bit, which basically removes any memory restrictions. And so you can work with these very large regional scale projects with lots of 2D data and 3D data, or with prospect level single 3D surveys, or even a single 2D line if you want. We store the seismic for both 2D and 3D data in a proprietary brick format. Our SegWi loaders take SegWi data and convert it to our format. It's an easy visit-based interface and can handle most commonly encountered scenarios without much difficulty. We also have several tools to optimize visualization speed. That's one of the reasons we have the brick format. It makes visualization much faster. So if you work a lot with horizontal seismic, for example, you can create a brick file in the time orientation for your survey, and that will dramatically reduce the time taken to render a time slice. We also have level of detail support, or LOD, that lets you break big seismic files into multiple resolutions. So when you're scanning your data, and it's a big file, something like 100 GB of seismic, data will load almost immediately from the low resolution part of the file. And it will give you an idea of what you're looking at. And then as you see something of interest and pause, high resolution data is fetched, and you're able to see the details of the structure or the feature that you're interested in. Once you have your data loaded, you obviously want to visualize it. We're very proud of our new 3D viewer. It is one of those areas we're really good in. Our viewer is fast, it can handle large amounts of data, and it can really hold its own when you compare it with any other 3D viewer available on the market, including Petrel. The workflows are easy and intuitive. It's a true ribbon interface. We don't just use the ribbon as a glorified toolbar. We have multi-screen support. You can save the entire scene as a session and load it up later, and even share it with your colleagues. Lock your 2D and 3D views together, keep them in sync. Full cursor tracking between your 3D scenes, between multiple 3D scenes, or between the 3D scene and your map. We've also tried to make it as easy and intuitive as possible, and the learning curve is not very steep at all. You can view all your seismic data, 2D, 3D, inlines, cross lines, arm lines. You can view probes, which are cubes with data displayed on the sides. You can even render voxels to visualize volumes and use our color palette controls for selective transparencies. That lets you visualize what's actually going on inside your volumes. You can, of course, also view your horizons, faults, geobodies, attribute surfaces, basically all of your interpretation data in 3D scene. Excuse me. Our seismic and well displays are very versatile. You can display wiggle overlays, apply on-the-fly phase rotation, bandpass filters, and other basic processing directly on your seismic sections. Set default color palettes based on data types, and do all of this in both the 3D scene and the traditional vertical and horizontal seismic views. You can also view wells and post-well data. This includes formation tops and fault cuts, well logs, microseismic data, production data, synthetic traces, which you can also manipulate, shift, stretch, or squeeze directly in the 3D scene. You can blend different versions of seismic on your sections or on your horizons. So for example, overlay semblance data on top of your seismic to get structural information from the seismic and highlight the discontinuities using the semblance data. So a lot of strong visualization features that enable us to then provide an environment where you can start to put the building blocks of your interpretation in place. Let's start with horizon picking. As you would expect, we have a variety of manual and auto picking modes. This includes a new correlation-based 2D auto picker. We've always had the 3D correlation picker. We have now added a 2D tracker with correlation as well. Instead of just snapping to the nearest event, the new picker considers the correlation factor, and not just for the next trace. It actually figures out which path from point A to point B has the best correlation overall, and then marks picks along that best correlation path. Multi-Z picking, I've been over that before. That's not something a lot of other softwares can do. For us, the limitation there is that it only works on 2D data sets. Nevertheless, this is a good feature to have when working in thrust faulted areas. We've also recently added a lot of QC features like horizon attribute maps. So you can create confidence maps, look at the pick order or pick type, even pick relationships, which tell you exactly where a specific pick came from. You can edit your horizons based on these attributes as well. That gives you more control over your picking and makes the QC process much faster and less reliant on just eyeballing the thing. We can project horizons onto unpicked sections to serve as a guide of where the horizons fall when picking manually. We have a range of horizon operations, including dip and azimuth calculations, and the ability to convert your horizon to a grid and even create horizons from isomap layers. And we keep adding small new features, which I haven't really mentioned here. So for example, recently, we've introduced the ability to fill the small gaps left behind when you do a 3D correlation pick. So these gaps that are left behind can now be filled without creating a complicated polygon or multiple polygons. And you can do it now with just a single click. And there are many, many other things that I just don't have the time to get into right now. But everything has been designed to make your horizon picking faster and more reliable. For fault interpretation, excuse me. For fault interpretation, we have just introduced our automatic fault tracking and interpretation feature. That is comparable to what you might be more familiar with in Petrel as ant tracking, but we use our own algorithm where we combine a few different attributes in different dip and azimuth directions, and then detect edges in the data and combine them into fault surfaces. You can use these to automatically pick individual faults or run a bulk pick for your entire volume. When doing a bulk pick, we don't just dump all the faults that we find into your interpretation. We let you QC them, analyze them, and then we only put faults that you want into your interpretation. We have merging, splitting, batch reassign, editing, all those tools available. We also have a new rows diagram that works for both actual interpreted faults or the temporary bulk pick faults to help you with faster analysis. We have several other tools designed to make fault picking easier and faster. So just like horizons, you can project your faults onto unpicked sections. We have a correlation window to visually compare the seismic signature around your fault on different sections. You can do manual or automatic fault polygon creation, which you can then also incorporate into your velocity models. Geobody analysis. This is also a recent capability that we've added to our software. So you can isolate areas in your data with similar seismic characteristics and save them as geobodies. You can simply interpolate your picks to create a structure, or you can define an amplitude threshold, like I'm doing in this little video that I have up. You can define an amplitude threshold and you'll scan the data. Any sample that meets your amplitude criteria and is connected to your original seed picks will be picked automatically as a geobody. You can use geobodies to, for example, isolate debris flows or bright spots in your data or whatever your use case may be. You can do volumetric calculations on these. You can build thickness maps or convert the top and base of the geobody to horizons to use in other workflows. Create layers out of these to take them to geology or to mapping tools. You can also use the attribute and surface calculator to compute various attributes within the geobody. We also have basic well top picking and editing within the geophysics application. So you can add or adjust well tops and fault cuts to your wells from directly the geophysical domain. Staying with wells, one of the most important steps in a seismic interpretation is creating synthetic traces. We've added a ton of functionality in our synthetic tool at every step of the synthetic creation process, and we've tried to make everything very easy. Creating synthetics was always simple, even when we were size vision. But now we have added a lot of things in there that are required for making a reliable, useful synthetic. So editing your input curves, creating different theoretical wavelets, or extracting them from seismic. You can extract wavelets from the entire 3D cube or a 2D line, or limit yourself to well locations, or even use traces from a specific section from right within the SynView interface. You can display the seismic and synthetic side by side, or the synthetic overlaid on the seismic. You can adjust the synthetic, of course, and QC your adjustments as you make them with drift curves and interval velocity plots. And we save everything in the database with the synthetic. So if someone deletes or modifies your input logs or your wavelet, you still don't lose your synthetic, and you can even restore the inputs you used to create the synthetic in the first place. I'm not sure how relevant this might be for you guys, but we can also now create synthetics for deviated wells within SynView. And like with everything else, all of this is included in the base license, so we don't charge extra for the synthetic functionality. We also have very comprehensive depth conversion workflows. We can build many different types of velocity models. If you're starting out on a project and you don't have reliable well data yet, you can use seismic velocities to create your velocity model. You can also calibrate that model with any existing well control that you do have. If you have reliable time depth tables and good well coverage in your area, you can triangulate those time depth tables and get your velocity model that way. If you have horizons marked, you can get the time information from the horizon picks and depth information from those TD tables of the well and create what we call a structurally interpolated velocity model. If you have formation picks in your wells that you trust, you can use those as your depth source and create a horizon formation based model. So many different tools available for any scenario that you may find yourself in. The way we store our horizons, you can extract velocities or depths along the horizon surface and save them to the horizon file itself. We are also tightly coupled with GVERSE geomodeling, so you can use your velocity model that you create in your interpretation to depth convert your seismic, time seismic, and display that as a backdrop on a cross section in geomodeling or smart section. And as you adjust your well picks or add more picks in the geomodeling applications, you can update your velocity model to include that new information. Everything happens in real time. The backdrop is always kept up to date. You can QC your velocity models that you build either by just viewing the velocity values along a section or plotting graphs for your wells velocity surveys and the velocities from the model, put them side by side to compare them. For the wells velocity surveys, you can also do user-defined velocity surveys, an interactive tool that lets you take your well and point on the seismic where you think certain formations lie, and we will build a velocity survey for you interactively. We also have a depth mode that lets you take a scene in your time interpretation and instantly convert that, the whole scene, to depth. This includes any seismic sections that you have in the scene, horizons, faults, geobodies, anything that you've added to the scene is converted to depth. And you can immediately tell what your structures will look like in depth, even though you're still in a time interpretation. A ton of other features like mist eye analysis, which we have recently updated, so you can now save all your shifts in a table, which you can export and import to as well. So if you have different shifts for different depths on your 2D lines, it's a simple update to the table to get you where you want to be. We have a robust attribute library, a new cross-plotting tool, gridding and contouring options for your attributes and horizons, and also a new AI-based waveform classification feature that we've just introduced. Now, and I will go into more detail about these when I answer some of the questions that we received. I really want to get to that part, but so I don't want to spend too much time on this here. But before we get to those questions, a quick look at some of the add-on modules that work hand in hand with GVERSE geophysics and give you access to some more advanced workflows. GVERSE attributes. This is our on-the-fly seismic attribute computation tool. This is a volumetric attribute tool, so it puts entire volumes. But it is unique in that it computes all these computationally expensive attributes and does that calculation on the fly. So it gives you a preview of what your attribute will look like on your data before you go ahead and commit to creating a volume. We have analysis tools like a synced multi-panel viewer that you can see in this animation, co-blending, RGB blending, even a 3D view built into the application that lets you compare many different attributes and their parameters before generating volumes for only the attributes that you think are useful for solving the problem that you're working on. It really takes the traditional approach to attribute analysis and spins it on its head. And our users are very happy with it because it takes something that used to take weeks to perform and reduces that time to days or even less in some cases. GVERSE Predict 3D, this is our multivariate inversion tool. This was developed in partnership with John Castagna's company, Lumina Geophysical. Castagna, of course, is a world-renowned scientist who has basically written textbooks on attribute analysis and is a pioneer in that field. This is also an AI solution where it takes your well logs and tries to match the seismic data using different attributes and spectrally decompose data. And it takes a log property like porosity or V-shale and tries to create a volume for you so you can get an idea of what's happening beyond your wells in terms of rock properties. We also have an inversion tool for computing relative and absolute impedances. PSTAX is our post-stack seismic processing module. You can perform processes like gain adjustment, filtering, convolution and deconvolution, resampling, and many others using PSTAX. It lets you create flows so that the output of one process can be used as the input of the next. Which means that you don't have to waste time, effort, and money of sending data back to your processor just to apply a simple filter or do a resampling. Our scan module also computes attributes like semblance and ESP to detect discontinuities in the data. Finally, we have logM. That lets you do advanced synthetic work like aviosynthetics or exploded synthetics. It is also our geophysical modeling tool used for structural and stratigraphic 2D forward modeling. So that was a quick look at GeoGraphix, GVERSE Geophysics, and the add-on modules available for your geophysical interpretation needs. Let's now get to some of the questions we received from PPL users. I will try to answer in as much detail as time allows. If you need more clarification, please type in your questions, and Mumtaz, hopefully if it's still online, can address these as we continue through the presentation. One of you wanted to see the improvements in the 3D viewer, which, to quote the question, gave a very old look. That's a fair point, no arguments there, because this is what our 3D view used to look like. And as I showed you during the first part of the presentation, we've completely changed the 3D view. It's much more modern and intuitive. We have a ribbon-based interface, tiered-away tabs, easy navigation and scene manipulation, a lot of capability too, in terms of the data that you can view and all the things that you can do with it. And we haven't just stopped at the 3D viewer. Updating our UI for all our various workflows is a constant process for us. So this is what SynView, our synthetic tool, this is what it used to look like. And this is what it looks like now. You can see a very sleek interface, and like I mentioned during the earlier part of the presentation, much more capable than before in terms of functionality. So it's just not just a pretty face, it's also got a lot of personality to it. Same thing for our interactive line balancing. Very old clunky interface replaced with something much more modern and easier to use, and also comes with a ton of new features. Okay, so another question was about data movement and communication mechanism with Petrel. I've gone over that in detail already, so I won't spend much more time on that here. GVERSE Connect is our tool that lets you transfer data to and from the Petrel software. It's two-way communication between the projects, makes transferring data between the two applications very easy. The next question was about extracting quick attributes like minimum amplitude. We have a very robust attribute library within GVERSE Geophysics. We call it the Attribute and Surface Calculator. You can compute up to 21 attributes, including minimum, maximum, mean, RMS, all sorts of amplitudes, isochron thicknesses, average energy, etc. So a lot of different attributes that you can compute. You can also use this calculator to compute various curvature attributes. If you want to do horizon math, we can do that here as well. Apart from this calculator, we can also do instantaneous attributes, your amplitude, phase, and frequency attributes directly on your seismic section. Just as I mentioned just a brief while ago, we also have over 50 volumetric attributes in GVERSE attributes. GVERSE attributes lets you preview your results before you compute your attribute. The scan module that I also went over briefly lets you compute some geometric attributes. So we have a lot of options when it comes to extracting attributes along horizons or within geobodies or just static time windows, and also for computing entire attribute volumes. Our color palette, somebody asked about this as well. Our color palette tool is a very advanced one now. So we feature a histogram that gives the data distribution for horizons or seismic sections or attribute surfaces or whatever you may be looking at. We support partial and selective transparencies that you can set up very easily using the histogram. If you don't particularly like the palettes that are shipped with the application, like was pointed out in the question, you can very easily create your own preferred palette or just modify an existing one. And the great thing is that this modified palette or this new palette will be available across the GeoGraphix suite and not just in geophysics. Depth conversion and velocity modeling. We covered this in detail as well. I think the most pertinent point here is the fact that we can create velocity models directly from seismic velocities that you receive from your processor. If you have well control, you can also calibrate that model with those wells as well. And we have also the other velocity model creation options that I mentioned earlier. So depending on how much data you have, how reliable that data is, we have several different configurations for your velocity models that you can use for your problem. There was a question about ant tracking. We don't do ant tracking. We have our own automatic fault interpretation algorithm. It's a very good one, certainly comparable to what Petrel has. The way we do it, though, we compute what we call a fault volume first. So you input your seismic. We calculate a semblance volume from that seismic, and then we scan this volume along different dips and azimuth directions, run edge detection algorithms, and then combine those edges that we find into fault surfaces. There's a lot of other fine-tuning steps in there, of course, as well, but that is the gist of it. Once we have the volume, you can then use that volume to either bulk pick all your faults, which you can analyze using a rows diagram and clean up using interactive merge and delete tools, or you can just go fault by fault or segment by segment and use the fault volume to simply assist you in your manual picking. So a lot of flexibility in terms of workflow. Data management and databases. We use a combination of flat files and databases to store and manage our data. All well-related data is stored in well-base. Seismic and associated data are stored as files. I have a schematic diagram on this slide detailing this. But regardless of how we store it, in databases or as files, all this data is available to all applications in the GeoGraphix suite. So we're fully integrated at the data level. There was also a question about data loading, PSTM, and new formats. I don't really know what was being asked here, but as far as data loading goes, we of course have comprehensive tools for loading seismic. We have SegY converters, also a SegY viewer, including detailed header analysis tools that let you figure out what's going on in your trace headers. PStax is our tool that can do some basic processing on your seismic file. PStax can also do this processing on your SegY files, so you don't have to be in our proprietary format to do that. We don't do migration or anything like that, but your basic filters, resampling, gain adjustments, all of that is available. We also do some on-the-fly processing on seismic sections, so you can do phase rotations or apply bandpass filters, compute your instantaneous attributes, and some other basic processing directly on your displayed seismic. We have a full-fledged coordinate management system that lets you even create your own coordinate system. So you can define your ellipsoids and datums and everything like that, and basically configure your own coordinate system. We handle all the coordinate conversions for you, so you don't have to do any of that manually, or don't have to worry about that. For our preset coordinate systems, we use Blue Marble, which is pretty much the industry standard, and we have a comprehensive library for those preset coordinate systems for around the world. Machine learning is an interesting one. We are just starting to make headway there. The 2019.3 release that's coming out next month will have our first AI-based workflow as part of the base package. We are introducing a waveform classification technique for horizons that can automatically differentiate waveforms for facies classification. We are using a self-organizing maps algorithm, or SOM, for it. You just specify the number of classes you want to divide your horizon into, and our neural network will go to work and classify all the different facies it can find and spit out a surface with a color-coded facies classification. We're also working on Python integration. If you're so inclined, you can access all our data and write your own machine learning scripts or use scripts that are already available to you with our data. This feature is still in progress and hopefully will be available by the end of this year. Predict 3D, and that's been around for a while, and I mentioned a little bit about it earlier as well. Predict 3D also relies on neural networks to figure out rock properties in seismic volumes by comparing logs to seismic data using artificial intelligence. We've just introduced a new cross-plotting tool. It's a very flexible. Sorry about that. So we've just introduced a new cross-plotting tool, and it's a very flexible tool in terms of functionality. It lets you take 2 or 3 seismic volumes and do a scatter plot, so you can see if there are any interesting relationships between those data. You can cross-plot the entire seismic cube. We take a random sample of about 2 million points when you're cross-plotting cubes and just display them on the cross-plot. But you can also limit your cross-plots to horizon surfaces, geobodies, or seismic sections. You can cross-plot seismic data at well locations as well. So you can take your seismic data at those well locations and actually cross-plot it with well logs to, if you want to establish or see relationships between petrophysical data and seismic. And the crossplot comes with a very detailed annotation toolset. So you can view your data distributions as histograms along your axes. You can draw trend lines and polygons to highlight points of interest. And if you see an anomaly in your crossplot and you want to view it in a map or in 3D, you can just right-click on it and send it to a map or a 3D scene. And we maintain a live connection with the scene. So if you move or modify your polygon, the change is reflected in the 3D scene as well. This is useful because the scatter plot doesn't really tell you where that anomaly is. So you can isolate that anomaly, send it to your map or send it to the 3D view, and we're going to draw it in the X, Y, and Z space so that you can see exactly where it is. This exact same crossplot tool will also become available in the petrophysics application soon. So they're going to be replacing their existing crossplot with this new one that just has so much more functionality. There was a question about 2D seismic modeling. LogM is the tool you can use to do that. It is considered one of the best tools on the market for this sort of work, and it is fully integrated with GVERSE GeoGraphix. So you can send your well data from your interpretation directly to LogM, do your modeling, create a synthetic 2D line, and then bring that synthetic model back into your GVERSE GeoGraphix to view and compare with your actual seismic and inform your seismic interpretation. We can also run on the cloud. We have customers already using our software on the cloud. We're not available as software as a service. The way we do it is that you acquire a cloud machine from the provider of your choice, Amazon or Microsoft or anybody else. And then you can install our software on that cloud machine. Then all you need to do is use your laptops to log on to the cloud and use the software. So very simple. This way, we don't keep data on our servers. None of your data is on our servers at all, and it's protected actually by the security features that these big guns of cloud technology like Amazon and Microsoft offer. This brings me to licensing. Not a lot to say here, but we do have different models for licensing. You can set up a licensing server or get a standalone license. We also have GVERSE Go, which is our pay-as-you-go licensing. So you pay for only what you use, and of course you get complete reports on what you're using and when and for how long and everything you would expect from a billing perspective. There were some queries regarding our fault mapping capabilities. So if you're mapping your faults on seismic, you first, of course, go ahead and make your fault mix. Once you have those, you can then find intersections of those faults with your horizons using the fault heave calculator, which also calculates the heaves on your faults for your faults at each intersecting horizon. Fault polygons are created automatically at each intersecting horizon, but you can always modify those or even digitize a fault polygon manually and ignore the automatic one altogether. Your contours will break at the fault polygons for those horizons that the fault is intersecting. And when you create a horizon layer, the fault polygon information is embedded into that layer as well. You can take that layer to GeoAtlas, where you can use the interactive contour editing tools, create grids from those contours. You can also adjust your fault polygons directly in the GeoAtlas application. So the fault polygon is actually made part of the horizon as a separate entity, and within the GeoAtlas application or in the geophysics application, you can actually modify that fault polygon as well. You can also map your faults using our structural modeling tools. We have a 3D topology engine that takes into account all your faulting. So even if you don't have any seismic, you can pick your fault cuts in your well data, create surfaces for those faults, compute fault gaps using vertical separation. And for the surfaces that you've already picked using formation tops, you can then compute your fault polygons for those surfaces from the formation tops and the fault surfaces made using fault cuts. You can also create fault networks and clip intersecting faults. We can also very efficiently map reverse faults using our multi-Z horizons. You can create multiple blocks to isolate structural domains within complexly faulted areas, like perhaps the northern part of Pakistan. Within these blocks, the horizon can then be independently interpreted and gridded. So how do you do this? You first have to create a multi-Z horizon and then create a fault that you have to specify to be a reverse fault. You pick the fault, you pick the horizon with multiple Z values, including in the overlapping areas. You can actually make separate picks on the footwall side, separate picks on the hanging wall side. You calculate your heaves, and then you just grid the horizon independently for the hanging wall and the footwall. That's simple. Okay, so here I've tried to combine 2 or 3 queries from you guys into a single workflow, which basically showcases how all the different modules of GeoGraphix can work together to start an interpretation from scratch and give you volumetric maps and other useful outputs. You can start anywhere, so let's talk about log analysis. The GVERSE petrophysics tool lets you do a complete petrophysical interpretation where you can analyze your well logs, QC them, edit them, create user-defined equations and petrophysical models to figure out some of the required properties from those logs, like porosity and water saturation, for example. We have a tool called Zone Manager, where you can create zones of interest in your wells, and all the rock properties that you calculate using petrophysics can then be populated into Zone Manager in the respective zones for each of your wells. You can then grid these in GeoAtlas and create maps of your porosity or other parameters of interest. At the same time, you can be working on your geological interpretation, where you can create cross sections through wells and pick your formation tops and faults on those wells. Use these to create your surfaces and an earth model with all this information. The petrophysical interpretation, of course, informs your geological interpretation, and you can also use the geological information over on the petrophysics side. If you have seismic data, you of course want to include that in your interpretation as well. You can use the log data from the petrophysics to create synthetics and tie wells to your seismic, and use the geological information to assist in your seismic interpretation. This can be tops to indicate horizons, or even pseudo horizons created from surfaces to act as guides for your picking. So you can take your surface that you picked from formation tops, convert it into a horizon, and bring that into your interpretation just to see how it correlates to your seismic. The seismic interpretation can be used to refine your geological interpretation. We have excellent velocity modeling tools that help incorporate seismic data into your geology work. You can also use our modeling tools for seismic modeling and use that to further refine your seismic interpretation. For your horizons and geobodies, you can compute many different attributes on them and also populate them into Zone Manager. So the Zone Manager gets a mix of petrophysical, geophysical, and geological data, which you can analyze further by creating maps for these or cross-plotting them. And just to clarify, you can also create maps for any of the outputs from your seismic or geological interpretation directly. You don't always have to go through Zone Manager. And once you have a potential reservoir identified and have created thickness maps for it, you can directly in GeoAtlas compute volumetrics using the thickness map, the porosity distribution, water saturation, and any other aspect like the recovery factor and so on. You can also create maps for existing production data for your wells and sort of combine that with all of these interpretation outputs to assist in well planning. All right, so there were a few questions about integration with drilling software and with ERPs. Unfortunately, we don't have direct connections with any of the software that was mentioned. However, there are workarounds. We support all industry standard formats for well and seismic data, so you can export your data to those formats for use with some of those applications. Or if you have access to Decision Space or Petrel, you can use our connectors to those software for use in specialty engineering or drilling software. So that's all from my side. I haven't been monitoring the chat, but I hope Mumtaz was able to address any questions that you guys had. For those of you who survived this onslaught, I'm going to now open the floor for any questions that you may have. Thank you very much.